Assalamualaikum and good day. Today, I would like to explain how to implement Lab2 using online. So, in Lab 1, we will discuss about coefficient of static friction. So, you can see in the lab sheet, we have learning outcome number 2 here, and also program on the number 4. Okay, you can see all information of the lab through this lab sheet. Okay, without delaying the time, I go to directly to the how to fill up the report. So by theory related to the lab 2, I will explain how to find out the friction and also the force of resistance. By using Formula 1, you can find the force of friction or resistance. I mean the force the friction, or we call the static friction here. And then in the lab sheet also listed all coefficient static, friction static from aluminium until to any material. So for example, I choose the aluminium and still have our 0.61 of static friction in dry condition. Okay, and then second one, I choose copper and still have 0.53 of number coefficient. Can see any couple of material different of static friction. Okay, how to find coefficient of friction? Actually, we can derive formula from relation of force resultant. Okay, I give you the example how to find out the friction, static friction. Here, for example, so I write here, one box in the medium, maybe plate, steel plate, maybe in the on the table, one of mesh, and then we can derive certain by variant of force. So we can find several force work in the object. So the first one, I give you W. W is come from the mass times to G. And then opposite of W, we have force in the normal. Normal always perpendicular to the medium. So medium is flat, so it should be perpendicular to medium, right? So Fn equal to W. Okay. So in the left side, this one we call F resistance, or in this case, we short form or denote by Fm. And then opposite resistance is force given. So we give force in the into right side, the x direction. So opposite of force is resistance. So how to get F resistance is by formula Fm equal to Fn, yes, Fn times 2 mu Mu is we call mu s, mu or friction static. Yeah. So from this formula, we can simplify how to find a friction. Yes, this one. So now you know where is the formula come from. Okay, now this one is formula from the flat or theta equal to 0. Okay, now we go directly how to answer or fill up the experiment, how to run experiment. So actually, the experiment I will simplify from this setup, experiment setup. So actually, if we go to the experiment setup, we will use the mesh. So the mesh will put in the uh, medium, maybe medium in steel, and then the mesh maybe will vary it by material, different material. The first maybe wood, and the second one a plastic, and the last one maybe we'll put by bronze. But in this case, uh, we will use maybe only two types of material. Okay, then this mesh combination within the load uh, in the mesh of wood, for example, and then also in the medium. So the total this we call W or equal to mg. So total wood and then the medium, and then the string will hang by the load. The load in this case will vary, but because we don't have the setup, uh, experiment setup, so we change by using the simulation. The simulation we can find from the website. So I already put the website here. Okay, you can click here, and then you can go to the yes, go to the website. So I will go to this website to explain. Yeah. Okay. But before that, I will explain the step how to run simulation. The first one, put a wood box 1 kilogram with the load 0.1 Newton on it on the mild steel surface. But in the simulation, we only have one type of material. Don't worry, don't put two type of material, but you only put one type material itself. I will explain later, and only one mesh. No need to sum by two material. Okay, and the hang of load hanger on the steel box with the string we change. In the simulation, we use a force acting in the object. Okay, so actually we can change the string force by actual force work directly on the object. Okay, so MB total mass of the box, wood, and total load it, I will determine directly. No need to sum by two material. And then also ML total mass load hanger here, hanger, I also determine directly. So just use it. Okay. And then by variant of different coefficient static from 0.3 until to 0.6, you put in the simulation. So how to use the simulation? So I will show now. Okay, now we are already in simulation online that I shared you before. Yeah, can you see here? Okay, now I use the variant applied force that I mentioned in the table. Okay, already in the table. Just set up, yeah, you click show here and then click force vector here, tick all, yeah, and then we'll show the view uh, like this. And then apply force, you try by variant that I share in the table. Okay, and then for static friction, yeah, I also share in the table. You can vary it yeah, from the data in the table also, the same table, and then you can click run here. Run is just click play. So you can see the simulation. Yes, yes, the object starting moving from the initial position until to until to finish. Maybe you can stop until go through to uh, 10 meter. This one in the 10 meters of user measurement. Okay. After that, uh, after you run here, you can stop and fulfill the you can fulfill the table here. Yes. So we have the constant load hanger actually, and then varied by mass. Kinetic, static. Sorry, coefficient static. Yes. Then by calculation, you can find variant of friction, resistant force. I mean, yes. Then MB is total, yeah, total mass. So total mass you can see in the simulation by 1 kilogram. Okay, here you put 1 kilogram, and then you can find by calculation is FM. FM mean resistant, force resistant. By using a formula uh, previously I already explained. Okay. Okay. Now we go to table number 2. Uh, by different of kinetic, coefficient static. Uh, Also by 1 kilogram of mass, and then on constant load of hanger, and then find the friction, resistant, force resistant. Okay. After that, by changing the friction, uh, you can also find the friction. Sorry, this one is force resistant. Okay, same thing. Okay, now I would like to explain by different angle. So this one consider previous one consider 0 degree. Now we go to a varied angle from the 30 until to 45 degree. Okay, go back to the simulation because the simulation within the angle 30 and the 45, we will use different of website. Okay, just click here by variant of angle. you can see the link here. Just click here, and then we can get the simulation like this. Okay, I will share you. Now you can see the simulation by using the variant angle. Okay, in the variant angle, you can play here with the constant mesh. You choose a file cabinet with a 100 kilogram of mesh and with the kinetic mu, static coefficient mu equal to 0.3, and then you set up here angle. So you can choose the angle first is 30. So after you choose the 30, and then you select the force applied. So for this applied force, you can see from the table also. So I already share there, variant force, we will work. And then you can play, go, and then same thing, you should be find the force, friction force. How to get the friction force. So we go back to lab sheet. Okay, here, lab sheet mention that the mu constant, mu s, coefficient static is constant, but variant of number force. And then for load of hanger, it should be, load of hanger, it should be variant from 700 until to 800. But the mass of material is constant, 100 kilogram, and then you calculate into the Newton. Newton times to the gravity, almost 1,000 Newton. Okay, so mass with the kilogram is 100 kilogram, and then if gravity consider 10 meter per second square, so almost 1,000, yeah. So 1,000. So the force here variate, and then find the friction force. So the theory of friction force. So the same thing, how to find in the same thing, yeah. The same thing, how to find in the angle of 0, but in the angles condition, the mass in a certain angle. I hope you already understand from the lecture class. Yes, like this. This is W, And then this is W cosinus cos theta. Okay. And then this one is negative to W. Cosinus theta. Okay. Okay. From this condition, please find the the resistant force. Yes, like this, almost finish. Yes. Okay. After you calculate, please fill in the same thing. So we change this one. Okay. After you get it, and then please fulfill the graph by plotting how ML vs MB by variate the angle. And then plot it, and then also another one, ML versus MB, then and so on until the finish, and discuss how to friction work in this experiment. Please fill up all the question and conclusion. Okay, I hope you understand. That's all presentation for explanation in the lab 1. Thank you.